Yes, sir, going on. Yes, sir. Sir, give me some papers.
So you told us you'll be giving us the topic or the concept, sir.
Yeah, yeah, sure. Concepts, I will share it.
Yes.
I'll share the concepts. But meanwhile, I thought you will practice, right? Because the concepts, right? Okay, I will give you the concepts.
Yes, sir.
Mm, But almost every concept is important. Okay, because we are yet to cover few of the concepts. Um, Once those are also done, then we will be good. But okay, you sure the concepts with you. So I will share the concepts, and you guys will prepare it, right? Prepare in the sense, like everyone
Yes,
will
sir.
prepare the demo on all those concepts, right?
Yes, yes, sir.
Okay, fine.
We'll be doing with the PPT, sir. Presentation of it.
Come up with PPTs. Okay.
Yes, yes, sir.
Fine, fine. Let's. I will share the concepts. Okay. Yeah. Arun, let's give them one more minute. On Saturday, we will connect on the same time. Okay. So 5:30 to 6:30. Is that fine, right? Sorry, sir. Not Saturday. On Sunday. Sunday, let's connect in the morning. That's fine, right?
Yes, sir.
Yes, sir. What will
Let
be the
me.
time, sir? Sunday?
Your wish. If you guys okay to wake up early, early in the sense 9 a.m. 9 a.m. to 10 a.m. something. So it's up to you. Like the if you it's up. It's only for the demo purpose.
Yeah,
So if you give
morning is
demo,
fine for
hmm,
me. It's 9 to 10 or
9 to
8:30
10.
to yeah, that time is fine.
Okay, fine. I mean, it's up to all, not one person. So Veda is okay. Seems Karthik is okay. You are okay. And Deepthi, Arun, if both are okay, then we can have the call at 8:30 to 9:30 or 10. Just you guys need to give demo. Maybe Sivasri and me will be there. We might ask some questions, but yeah, you just need to give the demo. That's it. There'll be no fuss. It's
Okay.
up to you. Like if the demo is completed very fast, then we can like the once your demo is completed, if you want to exit from the call, you can exit. Anyway, you will have the recording right for others demos, so you can go through that if there is important task. Okay, so seems let me post them. You guys know right that every day we have call at 5:30.
Yes,
Yeah,
yes.
yes, sir.
Yes, sir.
Okay. Okay. Meanwhile, let them join. So meanwhile, let's go through concepts. Okay. Yeah. Okay. So to start with, so today class we are going to discuss on persist and caching. Okay. Persist and caching. So what is persist and caching? Okay. In the real time, right? In the real time, in the real time data engineering task, there are few things, a few tasks, let's say few tasks or something, you need to calculate them again and again. Okay, I will tell you the scenario. Okay, um, let's say, uh, there is a task. Okay, let's say there are 10 users. Okay, 10 users. Let's think of Amazon, Big Bill and ASL. Okay, let's say there are 10 users. Okay, so out of this 10 users will be in customer table. Okay, customer, like let's say my all my details, I'm a customer to Amazon, right? So all my details will be stored in customer table. Okay, now all my orders will be stored in orders table. Okay, now payment details will be stored in payment table or transaction table, whatever you call. Let's go with three tables on three tables. Okay, customer table where all your customer data lies. Okay, and payment table, or we can call it as transaction table as well. Transaction table where all your orders, I mean payments, payment related information. You done it via credit card, it will capture there. It will get captured there. So you done it via UPI, Amazon Pay wallet, anything, in any type of mode. What is the transaction ID? All these things will get captured there. To which order ID, which customer made that payment, everything, right? And in coming to the orders table, that means which order was ordered by which customer. So what was that order and all these things. You will have product tables as well, all these things. But for now, let's not consider that, because there will be product ID only. In that orders table, you won't have entire product information. You will have just product ID. Okay. So product ID will be, let's say, I 172025. That's it. That means this ID belongs to iPhone 2017 model 2025. Okay. So then if you want to have those details, exact details of that product, you need to go to products table and search for select star from product table where product ID is equal to I1725. Then it will give you the details. Okay. So let's forget about the product details for now. Let's go with the customer table. Okay. Customer table, orders table, and payment table. Okay. So you think, right, these 10 people, right? 10 people can place lakhs of orders, right? It can happen. It can happen. If you see in the social media, there is this person who ordered almost 449 orders in a year. Okay, that means every day one order. Okay, so they
Yes,
can do
sir.
it, right? These 10 people can definitely do that order. Okay, now
Excuse me, sir.
every time.
So,
Excuse me, sir.
Hello.
Yes, sir.
Sir.
Sir, actually, the screen is different, sir, which you have shared us. We cannot see any customer table and all over there.
we
No,
can
I'm not
see
sure.
only the PPT.
You can see only.
The
PPT.
The
PPT only.
PPT, sir.
No. Actually, I'm showing on the PPT. I'm not.
Okay.
Okay.
Okay. Yeah, so I'm just walking through the example. Yeah, because this Amazon, right, Amazon table, customer, and all these things, it's a very good example. So whenever someone gives you any problem or something, you can relate to with that. Okay. Now, for all these 450 449 orders that this person placed, right, that person, so he's very lazy, that's why he placed 449 orders in Amazon. That was record by a single customer. Okay, so these 10 customers can do that. Okay, can do that. Okay, now whenever any order happen, then I wanted to see who ordered that. Who ordered that? That means I need that there will be order ID, and customer ID, product ID, transaction ID. Okay. Now I wanted to know who ordered this. That means I need to go and load my customer table into cluster and then join with this order into to with my customer. Then I will fetch who is that customer, right? So without customer ID, you cannot find who is that customer, the customer name, right? So again, let's say Anusha placed an order. Okay, that means in order ID, how it look is order underscore some random number, order underscore, let's say today's date 9/10/2025. Okay, then customer ID will be, let's say Anusha say customer ID. Let's say one is customer ID, Anusha's customer ID. Okay, then she ordered iPhone 17. That means IP 2025. That's it. That's the product ID number. Transaction number, some transaction number, T, and some random number. Okay. Now, if you know that, that's it. You do not know that this customer ID belongs to Anusha. Right? You do not know that. How you can know that? If you join this orders table with the customer table, right? If you able to join, if you are able to map this customer table with this orders table, then only you will get to know that, okay, this one ID belongs to Anusha, right? Then only I will get to know. So that this process is called enriching of the data. Okay, the moment you see this order transaction, maybe let me quickly do. Okay, let me quickly do. So let's say order underscore 123. Okay, so order ID, customer number will be customer 123. Okay, and the product ID will be product underscore 1, and the transaction will be transaction underscore 2. Now, can anyone let me know who's this? Who made this purchase? I wanted to know the name of this person who made the purchase, who made this order, who made this order. Okay, this will, let's say, delivered or shipping. Let's say. So can anyone let me know what is the name of this customer? Come on, you can unmute yourself. Hello?
Yes, sir.
Can anyone let me know who made this transaction? Who made this order? You know, mm, like yes or no, something. Just just be open, no problem. Karthik.
Sir.
So can you know? Can we know this? How the what is the customer name of this customer 123?
No, sir.
Hmm?
Sir?
Can we get that customer name from this orders ID, this orders row?
Yes, sir, we can actually get it.
Okay, how?
Uh, by just entering that number, we will find it.
Okay, which number?
123.
The order number, so that
Order,
their complete
this is
details
orders
will
table.
be showed.
Orders table. Okay. So in this order step, this is order 123. This will speak about the order. This order 123 is placed by customer 123, product 1, transaction number 2, and its in current status is delivered or shipping. So let's say delivered. Okay, delivered. So now how can I know that this customer 123 name? What is the name of that customer or location of that customer? Customer details. How can I know these customers details? Okay, so I know
No,
why your faces are blank because we have customer table as well in the real time. Okay, customer table as well. Then customer 123 is a name. Let's give name Virat. Okay, and let's say address will be Delhi. Okay, fair enough, right? These are the things. Mobile number will be some 123 456. Okay, so this is the mobile number at all. Okay, now can you show me like can you know the details? Now can you extract the details of this customer 123?
yes, sir.
Hello,
Yes, sir. Yes.
how you are going to get these details of the customer 123? How you get going to get the name of the customer 123?
Customer table, we store the customers.
Sorry, customer
In customer table, store the customer, customer ID and name.
customer table stores the customer ID and customer name. That means if you are able to select, let's say, select a star from, if you guys are practicing, this is very easy problem. Okay, select a star from orders table. Okay, inner join, customer table on cust ID. Okay, that means both these rows will get into one row, right? Okay. Now again, this customer 123. Only this here because I already have the customer 123 here. Now it makes proper information, right? If you see here, this order 123 is placed by customer 123, and he made order for product 1 with a transaction number, let's say 098765 transaction number, and that order status is delivered, and the person's name is Virat, and he belongs to Delhi, that's the address, and this is the phone number of it. So by joining these two tables, you are able to get the full details, right? You are able to extract the data. So when you look at this orders column here, right, orders row here, do you have any much, we have very less information, right? Someone made purchase, someone, because I'm not sure who is this customer 123, I'm not sure, it's someone to me. So someone made an order of 123 with product 1 transaction, some transaction number, and that status of that order is delivered, that's it, right? But when you join these orders tables with the customer table, then you will get to know who is that someone. He, in our case, the someone is Virat. Okay, so you will get to know these details only if you join the table, right? you'll get more information. See, now tell me, this orders 1 to 3 has more information, or this has more information? Which of these two rows has more information? This or this? This or this? Which one? First one or last one?
Last one, sir.
Last one. Because you added the data, right? You added the more details, right? This process is called enrichment, data enrichment. Okay, remember this. Maybe in coming classes we are going to discuss this thing, data enrichment. Okay, data enrichment, that means you are adding more columns to that row, to more values to that row, so that whenever the moment you look at it, it's more meaningful to you, right? So now, before this row, you can see here and say, who is this someone, who is this customer 1 2 3? You never know, right? Unless you join it with customer table, right? Okay, fine. Now we understand what is data enrichment. Okay. Now in real time, what happens is, let's say there are 1 lakh products, sorry, 1 lakh orders. Okay. For that 1 lakh orders were placed by, let's say, 100 customers. Let's go with the statistics. 1 lakh orders placed by, let's say, 100 customers. Okay. Now, similarly, for this 1,000 orders, 1 lakh orders, right? I need to get the similar details, like who made that order. The moment I look at that row, that I need to know that, okay, this order was made by so and so person. That means I need to do data enrichment. That means for all this 1 lakh orders records, right? I need to join that with my 100 customer details, right? You need to join, inner join with, let's say here the id is customer, similar like to this customer 1 2 3, then join it with customer table 1 2 3. That's it. Then you'll get to know that these details, what is his name, where he belongs to, what is his phone number and all, right? If you do data enrichment, right? Why I'm talking about all these concepts is, in real time this customer table you need to load multiple times, right? Multiple times. Sometimes this customer table needs to be loaded multiple times. Okay, multiple times. Now every time you load it, do some processing, and again you do another processing. That means your, the moment you wanted to use the any data frame or any values or something, any data multiple times, multiple places, multiple stages, okay, anything in multiple stages, multiple tasks, multiple place, then the best idea is to go and cache it. What is meant by caching or persisting? So if you know the English meaning of the persisting means, it means, what is the persistence meaning, persist meaning, English meaning? Anyone? Persist meaning, English meaning. Persist or cache in English meanings. No
Sir,
one?
it keeps on this thing continue.
It keeps on
Something that exists where it will be continuous.
continuous existence, right? Exactly,
Yeah.
continuous existence, right? Same here, same concept here. So we have two methods here in Spark, persist and caching. Let's see what is that persist and caching. And me before that, does Arun and whether join, right? Okay, Arun about the join. Okay, fine. Okay, let's see what is that. Now you are able to understand, right? What is this customer table? What is this orders table? And why I need this customer table multiple places? Because there could be multiple things, right? Multiple things in the let's say here only. Let's go. Okay, let's go and say transaction table. Transaction table. Okay, let's say transaction number. Let's go with TN098765 something 565. Okay, this is a transaction number, and order ID will be, let's say order ID will be order 123, customer ID will be 123. Okay, something. Payment mode will be credit card. Okay, right. Now, if you wanted to know who made this transaction, how can you do that? Who made this transaction? How can you do that? How can you know that someone made this transaction? Who made the transaction? How can we get those details?
By knowing their transaction details, sir.
Transaction details, But how can you get the customer name here? Someone made this transaction, TN098 But who made the transaction? How can we know that?
Is that
It should
customer
be
Mm.
customer
table
customer number,
customer.
Hmm.
Yes.
right?
Yes, sir.
Exactly. So here, if you see in the orders table, if you wanted to enrich the data, you use this customer underscore 123. Right? Similarly, here the transaction table, if you wanted to know who made this transaction, okay, so you need to go with this customer 123. Okay, so this customer 123, if you join this transaction table with customer table on key this customer ID, then you will get to know the details, right? Exactly, right? So that then you will get to know this thing. Now, after joining, my data will look like this. Now tell me who made this transaction? Come on. Who made this transaction now?
Virat.
Virat. How can you how we got the details? With the help of which column or which record or with the help of what?
Uh,
Customer ID
with
and
the help
order.
of customer number.
Cust- Customer number and customer table, right?
Yes,
That means
yes.
if you see here also we use customer table, right? Here also we join with customer table. Here also we join with customer table. That means customer table we are using in multiple places, two transactions, two different places. Okay, you got that right? So two different places. Okay, so that means you need to join this customer table with this transaction as well. I mean, this orders table as well, and along with this transaction table as well, two different places we need to use this customer table. That means if you wanted to use like now what happens is in real time, if you're not caching or not persisting, what happens is first it will load the customer table. Here you're joining that, this is your thing. So the moment you have an action, it will get triggered, right? What it will trigger is it will take this customer order table first, load the order table first and customer table next, and join them and give the result. Okay, that's it. Again, the customer table and order table will be discarded from the cluster. Now again, it will come here to load the transaction table and the customer table, and again it will calculate the results and it will discard. Okay. Now here, order table is loaded how many times? Order table how many times? It's loaded how many times? So here order table is loaded how many times? One time, right? Only one time you used it. So one time only we it loaded. Okay. This is also one time. But customer table how many times? Come on. How many times customer table is loaded here?
3 times, sir.
How many times?
3.
Three.
Or
One time only.
because it comes under order number,
Order?
even in the customer also. With the customer details also, it will be included in the customer table and all.
Yes.
And with the transaction also.
Okay. So two places, right?
Yes, sir. 2 or
Two or three?
3, sir.
Three you
3,
say.
sir.
Okay.
Because in the transaction, order and customer details,
Order
sir.
and customer. Okay. Here in the order, see one thing I'm asking,
Here
how
we'll have
many times the customer table need to be loaded? Okay. First time, when did you use the customer table? With which table you use the customer table? First time you use the customer table with orders table, right? Now,
yes.
second time you use the customer table with the transaction table,
Mm,
right? So you use two
yes.
times. Two
Okay.
times here. That means you need to load a customer table twice. Let's say there is one more table here. Shipping. Shipping details. Shipping details will definitely need to have your details, right? Then you are going to use this customer table one more time, right? So if you see these three are only one time loading, but this customer table we need to load three times. That means multiple times we need to load this customer table, right? So in those cases, we will go with the caching or persisting. This what happens is instead of loading this customer table again and again into the customer cluster, Spark cluster, what Spark will do is it will load it once and cache it there, cache it there, cache it or persist. That means what happens is in future whenever this order or transaction or shipping, whenever you call customer table, it will be readily available. Okay, it will be readily available. Okay, so that's good example, I think. So you can, if you do not understand, just try to Google it and see what is the difference between caching, why caching is needed. That's it. So if you go into Google, so why caching is needed. Okay, see, more makes Spark store them for future use. Simple. Simple. I could have told them, you could have stored this customer table for future use, but this is the real time. Okay. So in the real time, what happens is, if these data frames are expensive to regenerate, this will massively speed up your Spark job. Use cache when you want to save the data frame only at the default storage level. So the storage level you can ignore, but yeah, just note this. Make Spark store them for future use. That's it. Okay. Simple. What caching or persisting will do is make Spark store them for future use. That's it. So in future, I told you, right? This customer table, in future, you need that customer table. The moment you load the customer table, let's cache it. Let's persist it. So what happens is, in future, whenever customer table is needed, I can utilize this caching. Right? So that's how we can. Now, let's go one by one. The method persist and cache in Apache Spark are used to save the RDD, okay, data frame or data set. So this RDD part you can ignore now. Why? Because I will tell you, in the current market, it is recommended to use data frame only, because we never going to, maybe you in the practice time you use this RDD, but in the real time, mostly we will go with the data frame only. So data frame is very much optimized and everything. But you might think like, what is data frame and all? So I will let you know those concepts in the coming classes, okay? But for now, just remember this thing, what these words: RDD, data frame, and data set. In memory for faster access during computation, right? Now they are effectively ways to optimize the execution of Spark jobs, right? Execution of Spark job. Why? Because let's say loading customer table takes 1 minute. Okay, 1 minute. Now order, like each table loading will take 1 minute. Okay. Now let's go here. I want you to answer. So orders table will take 1 minute to load, get loaded into cluster. Transaction will get loaded into uh, take one minute to load. Shipping 1 minute, customer 1 minute. Now tell me, without caching, how many minutes does it take to load all these tables? Come on, each table will take only 1 minute. Any update?
1 minute.
Hmm?
1 minute.
Simple. You see, first you will load orders table and customer table. 2 minutes. 2 minutes. Plus, again you need to load. Once this is done, customer table and orders table will be discarded. Now you need to load again the this transaction table and customer table again 2 minutes. And again, this customer table and transaction will be discarded from the cluster, removed from the cluster. Okay. Then again, you need to load customer table and shipping table. Again, 2 minutes. That means in total, 6 minutes. Okay. Now let's say you have used the caching. That means in the first time you will have 1 minute for customer. Okay. 1 minute for orders, and from then, with the transaction, when transaction only loaded, there will be no customer again. That means no customer loading again, because it's already cached. Cached. Customer is cached. That means no need to load it again. So again, 1 minute. Now 4 minutes. You see, there is a difference, right? With the help of caching, you are able to reduce the number of time that the job takes to load the data. Right? 2 minutes at least. Think in real time. This 2 minutes can increase to 20 minutes. Some cases. Okay. So that's why the caching will speed up your job. Okay, execution of your Spark job, especially when you have repeated transformations on the same data. Right? That's what we are thinking. We are discussing, right? So whenever there is a repeated transformation or repeated things on the same data, let's cache them. That's it. Okay. So and also while caching, you need to take few precautions. We will discuss that in the coming days. Okay. Okay. Let's see. There are two things: cache and persistence. Okay. So I told you, right? Spark is in memory, but along with in memory, I mean along with the RAM, there will be ROM as well, right? ROM as well and RAM as well. Okay. So whenever you cache it, right? Cache it. Cache it. It will go to The default storage is what do you think the default storage? The default storage is anyone? RAM or ROM? Come on, I need you to be attentive. No one? Any idea or something where this data will get loaded into? Okay, so the moment data is loaded into Spark cluster, where the data will be loaded into? Is it into RAM or ROM? Let me know.
RAM.
RAM, right? RAM. And ROM, you will never go unless it's a data spilling happens, the cluster size is less compared to the data, so you will never go. So it's a RAM, right? RAM. Okay. Same. This caching will happens in the RAM only. Okay. The caching will happens in the RAM only. So in the RAM only at any cost. Okay. But if let's say you're caching something, okay, caching something, and that caching object, right, that object or data or whatever you call it, the customer is very much higher compared to your RAM. Okay, let's say your RAM is 2 GB, 2 GB. Okay, your customer is 1 GB. Let's say customer is 1 GB, or let's go with that is so your RAM is 2 GB, customer is 2.5 GB. Can it fit into RAM? Anyone? Your RAM is 2 GB, customer is 2.5 GB. Can it fit into RAM? Is 2 GB greater than 2.5 GB?
No.
You guys speaking, I'm unable to hear or what?
Yes, yes.
Is 2 GB greater than 2.5 GB?
No, sir.
No.
No, right?
2.5.
So that means this this uh this customer table cannot fit into the RAM, right? This customer table cannot fit into the RAM. Then what happens is, uh, when what happens whenever you cache this customer table, it will fail. Okay, so that's why we will do intelligent caching. So we will look at our cluster size and the data size as well. If data size is very much way less than the this RAM, okay, let's say this is 2 GB and our customer table is, let's say, 200 MB, then in those cases we can safely cache this customer table. If we cache it, let's say even with the 1 GB also, if the size is 1 GB, and 2 GB, uh, 2 GB is for our RAM size. Okay, if you go and cache it, 1 GB memory will be reserved for your customer table. Okay, customer table. Then your cluster has only 1 GB RAM, 1 GB RAM to do any processing. Okay, let's say you want to load one more 1 GB file or 1.5 GB file. You cannot load it here. Why? Because you are already 1 GB of RAM is utilized by this customer table for caching. Okay, now you have only 1 GB remaining. In this 1 GB, you need to load this 1.5 GB. Then again, you need to go to the data spilling concept. So where data will be loaded for 1 GB now, and rest that intermediate results will be stored in the hard disk. And again, this 0.5 GB will be loaded. Then again, the results will be get from the hard disk, and this 0.5 GB results will be combined. All these things will happen. Right. That means what I wanted to say is, whenever you do caching, right, you need to do very careful, because you cannot load every, because you can ask me, so what if we cache every table in the cluster, then it will occupy so much of the space, right? And it can never happen in the real time. What happens is, in that cluster, let's say 10 GB of cluster, let's say, so that 10 GB of cluster, you will be allowed to cache only up to 1 GB of data. Okay, if you go beyond that, then what happens is, let's say you cached almost all 10 GB of data, that means you have no space to load new data frames, new partitions, new data into your cluster, right? Then your job will fail because of memory issue, right? That's why whenever you cache it, do it intelligently in the sense, see what is your cluster size, what is your data size. Try to estimate. You cannot see it directly, but try to estimate what will be your size and all. Then accordingly, you will try to cache it. And the moment you cache it, it will be there permanently. Okay, until you uncache it or cluster is shut down. Okay, so whenever you cache it, try to uncache it as well. That means to cache it, it means you told you right, existing continuously. That's what we discussed. Continuous existing. Yet it will exist until it got uncached. Okay, so uncached or unpersistent. So what happens is persist, right? So let's say I told you, right? So if you wanted to cache, let's say 2.5 GB of data into 2 GB of RAM, then if you go with cache option, it will fail because cache will store everything in RAM. Okay, but if you go with persist, if you see here, there is storage level option. So you can define the storage level. Which storage level? That means memory and disk. So what you can say is let's store in both memory and disk. That means half of the out of this 2.5 GB, 1.25 GB will be cached. I mean persisted. We can say persisted in the RAM, and 1.25 GB will be persisted in the ROM hard disk. Okay. So in this way, you're managing. You want that file at any cost. You want to cache it or persist that data at any cost. Then what you can do? You can use this persist storage level concept. That means memory and disk. So half you store it in memory, half you store it in hard disk. In that way, it will be very helpful for you. Right? You do not need to. You won't have any cluster issues. The size is well within your range. All these things. Yeah. Perfect. Now let's see. This method is uh, short than shorthand of using persistence. So this persist, right? This persist is for memory and hard disk both. This cache is for only memory. Like if you call cache, that means cache of customer table. Then it will cache in the RAM only. But if you go with the persist of this customer table, it has two options: either to put it everything in memory only, or disk only, or half in memory, half in disk also. Okay, so that also you can do. So that's why whenever you wanted to do it in the memory, just directly go and do it from here, cache. Okay, with the default storage level. The method is shorthanded of for using persist with the default storage level. In other words, cache is equal to calling persist method without any parameters, right? That's what it says. And the default storage is memory and disk in PySpark and memory and disk serialization in Scala Spark. Serialization means yesterday I told you, right? SCR means serialization. I told you, right? Data needs to travel from the network. It cannot travel like high. It needs to be converted into some bytes or bits in the network. Then only it can travel by the network, right? Now, there are two options available. Okay, memory and disk in PySpark. So we will discuss only PySpark only, right? Memory and disk you can remove that. Memory and disk serialization is Scala Spark. Okay, default storage level. Okay. Now, this means that the RDD data frame or data set is stored in memory, and if doesn't fit, the access partitions are stored into disk. Okay, that's what it says. So by default, this cache, right? Cache app, what happens is you will try to fit everything into memory only. Okay, here what happens is it will try to fit everything into 2.5 GB into 2 GB of RAM only. But in some cases, if it doesn't fit the 2.5 GB here in this 2 GB cluster, the extra 0.5 GB will be written into the hard disk. Okay, so hard disk, fine, that's good. Now let's go and see what is persist. Persist storage level. This method allows you to control how the data should be stored, how and where it should be stored, in memory or in hard disk or in both. Okay, you can pass a storage level as an argument to the persist function, which gives you final control over how the data is persist. Right? So how you need to store the data, you need to cache that data, you need to persist the data. You can control it from here. The storage level can be of several options, each of which offers different trade-offs of memory usage and CPU efficiency. You can use either memory or disk storage. Okay, we discussed two options: either go with memory or disk storage or both. Okay,
Sir,
let's see here.
we
Yeah.
can't hear your voice clearly, sir. We can't hear your voice clearly.
Oh, I'm audible.
Yeah, but in between some sound is coming, sir.
Yes, sir. Same thing.
Okay. Same here. I'm in a very isolated place, so there's no sound. Let me put my phone and away. Maybe some signal. No, is it fine, right? No,
You
is it fine?
speak something, sir. The during when you speak only we can hear something.
Okay. Now is it fine? I hope this screen and
No
everything is visible.
problem. Still,
No,
is the
sir. Some sound.
Uh,
Disconnect automatically.
Okay. So now again it's saying to? I'm not sure where it
Your
is.
voice is not audible.
Sir, you're wearing microphone or something.
No, I don't. I'm not wearing
Can't
anything.
hear
Let me
anything,
wear it.
sir.
Let me wear it. Just give me a moment. Now is it audible for you? Is it fine?
Yes.
Yes, sir. Yes. Yes.
Perfect. Perfect. Mm, okay. So now it's fine. Okay. So till when you are able to hear clearly? So from that concept, I can start again. Till
You
which
start
part?
from storage level thing only, sir. It's okay.
Storage level thing. Okay. So first, two things here. So there are two options here. You wanted to store something so that you can use for future. Okay, you can use in your future use. So Spark wanted to store something. You are instructing Spark to store this data so that I will use in my coming task. Okay, you're taking that. Now to tell the Spark, you have two options: cache, persist. Okay, cache and persist. Now here, small correction. So I told the cache will everything will happen in the memory only if it's exceeds memory. Like if that data, like let's say customer size is greater than the size of the RAM, then it will fail. I told that no. So what happens here is if that customer size is greater than RAM size, that let's say 2.5 GB is greater than 2 GB of RAM. That means this entire 2 GB will be stored in 2 GB RAM, and that extra 0.5 GB, right, that will go and stored in the hard disk. Okay, hard disk. Now, can anyone in future can come and ask me that, sir, why I need to store everything in the memory only, in the RAM only? Why can't I store it in the hard disk? Someone will come and ask that question, right? Why can't I do that? So now what happens is that's why there is this. Then I will told him that, okay, we have a concept called persist with that storage level. So what is this storage level? That means it will give you the options. The option one is either store everything, entire customer table, if it fits, if and only if it fits, store the entire customer table in the RAM. Okay, or you can go and store it in the ROM. Okay, or you can go and store it in the both RAM, half in the RAM, half in the ROM as well. So you have three options here: either RAM only, or hard disk only, or half of. Right, we have that options. By default, cache will go with this memory and memory and disk. That means half will be stored in the disk, half will be stored in the memory. I mean, it's up to class Spark how it wanted to store. Maybe if it fits, if it might store everything in the memory only. If it doesn't fit, it will store some half of it's in the disk. Okay, it depends on the Spark cluster. Now let's go to the storage level. Okay, storage level disk only. See, disk only. Let's say RDD partitions. Okay, we discussed about this RDD partition. Let's say partition. So storage level dot disk. When you go this with this persist, right? Persist storage level dot disk only. The store the RDD partitions only on disk. Okay, only on disk. Okay. Now storage dot disk only underscore two. Okay, same as the disk only, but replicate each partition on two cluster nodes. Okay. Um, what it says is, how can I explain you this? So wait, let me come up with some example. um okay, let's say you have 10 partitions. Okay, now here I told go and store go and store storage level dot disk only. Now, where do you think these 10 partitions will go and sit? Can anyone let me know? I told here that storage level is disk only. Can anyone let me know where does this 10 partitions will go and sit? Anyone? Right, I asked Spark to store 10 partitions. The storage level I gave is, let's say, customer table dot persist of storage level is storage level dot disk only. Where will this customer table go and sit? Customer table has 10 partitions for time being. Where will this go and sit? Anyone? Okay.
No, I
Okay.
don't see.
Sorry, where?
No, no.
So you see here, right? Disk only, storage level not disk only. Then what happens? You will store all these RDD partitions only on disk. Okay, that's what it says, right? It's plain English. I'm not sure why you're not getting it. So it's plain English. Storage level dot disk only. That means all the RTD partitions will be stored in the disk. That's it. Disk in the sense hard disk for time being. Okay, hard disk. Okay, so it's plain English. It says, right, storage level dot disk only. Store the RDD partitions only on disk. Okay, now storage level dot disk only underscore two. It's same as disk only, but replicate each partition on two cluster nodes. Okay, each partition on two cluster nodes. Okay, along with same as disk only. Uh, so it will store everything in the disk only, every partition as well, but replicate each partition on two cluster nodes. Okay, so what happens is in the both the cluster nodes, let's say earlier the disk only means that means it will take any hard disk or something, any it doesn't mean that hard disk in the sense all this data will go and sit in the same place. Okay, it will scattered among the cluster. Let's say you have 10 node cluster, 10 nodes, 10 cluster nodes. This data will, these 10 partitions will go and sit into the 10 cluster nodes. Okay, but the moment you mention this disk only two, that means this 10 partitions will go and sit in two cluster nodes. Two cluster nodes. Okay. It's not going to scattered around all 10 cluster nodes. Okay. Simple. There are 10 cluster nodes, right? 10 cluster nodes, 10 worker nodes or 10, whatever cluster nodes. Okay. Now, the moment you ask the storage level or disk only, it's up to the Spark where it wants to store. But the moment you gave disk only underscore two, now you are asking Spark to store each partition on two cluster nodes. That's it, two cluster nodes. Okay. Out of the 10 cluster nodes, you will pick any two cluster nodes and let's store it. Okay. Then storage level, memory, and disk. Disk. Store RDD as deserialized object in the JVM. Okay. And if the RDD does not fit in memory, uh, it does not fit in memory, store the partitions that do not fit on the disk. Okay, so if you see here, if the RDD does not fit in the memory, store the partition that does not fit on disk and read them from there whenever they need it. Simple, right? It will try to store this RDD in the memory. And if that partition does not fit, then store on the disk. Simple, right? Simple, plain English. If RDD does not fit in memory, store that partition that doesn't fit on the disk. Okay. So see, deserialize everything you can ignore for now. Okay. If the RDD does not fit in memory, store that the partition that do not fit on disk, and read them from there whenever they need it. Okay. So whichever partition that do not fit, let's store that in disk. Okay. Simple. Now, memory and disk underscore two. Similar to memory and disk. What is similar to memory and disk? Memory and disk means store everything in the memory only first. First choice is RAM only. If it doesn't fit it, if that partition, let's say out of 10 partitions, 8 partitions are fit in the memory, and there are 2 partitions that do not fit on the memory. Now, when I go with memory and disk storage level, then 8 partitions will be stored in the RAM and 2 partitions will be go and get stored in the ROM. ROM in the sense hard disk. Now here. Now similar to memory and disk, replicate each partition on two cluster nodes. Okay, so the cluster nodes, that partitions will be replicated in the two cluster nodes. Okay, two cluster nodes. Fine. Now let's go with serialization and serialization 2. Similar, store RDD as serialized Java objects 1 byte array per partition. This is generally more space efficient than deserialized objects. Okay, especially when using a fast serializer but more CPU intensive rate. So what I would suggest is, as you are not getting these small concepts only, let's not go with this explanation, serialization and all. Because to explain this, I need to go with some concept. But serialization, to keep it very simple, the moment I send hi, the moment I send hi to in WhatsApp, right? It needs to travel to the network and reach the recipient, right? Then how it will travel is, it won't travel as HI in the network. Okay, it will travel as some bytes, some bits. Okay, if anyone has some computer fundamentals knowledge, then they can understand this. So the data you store, you send, it won't store, it won't get shared as it is. It will be serialized while to travel. Okay, it cannot travel via network without being serialized. Okay, so for now I'm avoiding this concept so that we can revisit in the future, or in future you can just wanted to know this thing as well. We never use this in the real time, especially never used. But if you want, you can just come and Google this. Okay, so that's simple. Okay, now let's go with storage memory. Memory only means, you know it. Memory only. Store RDD as deserialized Java objects in the JVM. If RDD does not fit in memory, some partitions will not be cached and will be recomputed on the fly each time when they are needed. Right? As I mentioned, memory only. That's a 2.5 GB of data needs to be persisted here. Out of that 2.5 GB, 2.5 GB, 2 GB can be persisted or cached in the RAM. There is 0.5 GB of data which is not persisted. Let's say, let's go with partitions, number of partitions. Out of 10 partitions, I'm clear, right? My voice is audible, right?
Yes, sir. Yes.
Um, so I will ask part two. This customer store this customer table. There are 10 partitions for this customer table. That means these 10 partitions need to be cached in the memory only. It cannot go to disk. Okay, in the memory only. But out of these 10 partitions, only 8 partitions can be cached. What about the two other partitions? It cannot go to the disk because I mentioned that it's memory only. So what Spark will do is, for now, as it can fit only 8 partitions, it will go and fit this 8 partitions only. The extra 2 partitions, right? It will it will compute on the fly each time they are needed. Okay, so that's what it says here. So store RDD as deserialized Java objects in the JVM. If the RDD does not fit in memory, some partitions will not be cached. Okay, some partitions, the two extra partitions which do not fit in the memory will not be cached and will be recomputed on the fly each time they are needed. Okay, each time they are needed. Perfect. So whenever they need, they will come back. Again, the same concept here, memory only two. So it will be stored in the memory in the two cluster node. Okay. Um, so again, this serialization came here, so you can ignore these two as well. This serialization two and this disk serialization two. Okay, these four you can ignore for now. Okay, that's what about the storage level. But I will tell you that mostly in real time, I'm going to use the cache only. Mostly 99% of the time, even 100% of the time, you're going to use cache only. Just learn how to use cache or how to uncache. Okay, simple, simple, simple. I'll show you the small example as well. DF customer table, right? I talking about. I told you customer dot cache. That's it. So this customer table is cached. I will do some transformation. Okay. Now go here. Customer dot uncache. I am doing uncache because I got I done this customer caching. That means it's stored in the RAM. Or if it doesn't fit, it some of out of let's say 10 partitions, only 8 partitions fit it in the cluster, then other two partitions will go and sit in the hard disk. Okay, Now, this transformations I apply on top of that, it will give the it has immediately give the values and all. It no need to go and load it from scratch again. It will give the values immediately. I will do the transformation again. Once everything is done, I'm caching it. That means I'm asking Spark to remove all these customer values or table or data from your cluster. That's it. Simple. Okay. So let me show you if I have any example. Um, Storage access in Spark. Mm, in Spark persist. Any images I can show you? Let me see. Okay, this goes disk only. Mhm. There's something or something. I think it shows something. Okay. So the moment it says persist, this is node one. Mm, So there are some records as well. So see, memory only means space used high of your memory. CPU time is very less because it's already in the memory. It can process it just like that. In memory, on disk, no. Memory only. So memory only serialization. Serialization means I told you right. Serialization means you need to convert the data into some bits or bytes. Okay. So space used is very less. That means very less space is used. Okay. If you convert Ravi, okay, Ravi means RAVI. That means 4 bytes of data. Okay. If you store this Ravi in a file in a okay. Let me show you some sample. Ravi. If you save this, let's say desktop. Mm, let's save this. Okay. We go to file. There is no properties and all right. Okay. Size of Ravi. Let's see. Okay. 4 bytes. You see 4 bytes. Okay. You see Ravi is 4 bytes. Let me go. Can anyone let me know what is the size now? Anyone let me know size?
8 bytes.
It's not refreshed. Let me refresh this. Properties. See, 8 bytes. Right? Now, if you serialize this, I cannot show you the serialization and all. So if you serialize this Ravi Teja will become like some 0012 not 00 1010001010 something that only computer understands. We cannot understand. This Ravi Teja will become like this. Okay. Now if I save this, it will give me again 8 bytes, but it won't happen because serialization means you cannot this humans cannot understand, right? Only computer can understand. That means this 8 GB, right? This Ravi Teja is 8 bytes if you write in a plain document. But if you do it in the real time, I mean with this serialization, this 8 bytes will become into 6 bytes. Okay, 6 bytes. That means very less memory space used compared to this. Okay, this Ravi Teja. Ravi Teja is 8 bytes, but if you go serialize that Ravi Teja, then it will go into some less space compared to six this 8 GB. Sorry, 8 KB. Sorry, 8 bytes. If it's plain Ravteja, 8 bytes. If you serialize that Ravteja, then it will go into some 66 bytes or 4 bytes something. Okay, cannot. Now CPU time. CPU time is high. Why? Because here this it do not need to process Ravteja, right? It can use the Ravteja as it is. But here it needs to process that. I mean, the moment it's serialized, that means it needs to deserialize somewhere. That means it needs to convert into Ravteja somewhere. I sent hi here. Okay, from my computer, it needs to be serialized into some 0101 something bytes. Bits we call them as bits because you know, right, computer understands only bits. 0101. It can never understand our language. This everything is built for our use case. Okay, but computer can only understand by bits 01010101 like that. Only 0 1 bits. Okay, whatever you write or in background it will be converted into bits only. Okay, so whatever you write, the CP time is high. Why? Because it's high because you need to deserialize it, right? That thing you need to take it and you need to decode. You know to decode it, right? So that's why it will CP time is high, and it's in memory because it will be mentioned in memory only. Okay, that's it. Now memory and disk. That means space used high because same space. Okay, medium. CP time is medium because half is in the memory, half is in the disk. That disk, right? From disk, I need to load that, I need to process that. That's where this medium is coming into which. Otherwise, it will be low. Okay, in memory some, on disk some. Okay, spills to disk if there is too much data to fit in memory. This spills to disk. Okay, now memory and disk serialization again low, space low because it's serialized. CPU time high. Okay, and in memory and on disk at least some. That means spills to disk if there is too much data to fit in memory. Store serialized representation in memory. Okay, fine. That's how it looks like. Okay, so this is the like real-time example in Spark. You can see this. I can show you if you start working on this. Okay. Um, let's see some good pictures. Yeah, you can think this as a memory, this as a memory. Okay, this as a disk. Okay, there are three partitions: partition 1, partition 2, partition 3. I asked it to persist. That means this out of these three partitions, right? This partition went into RAM, this partition went into RAM, this partition went into disk. Some visible. So it's going away. I cannot. Did you get the picture? What should I? Okay, so the persist this, right? See, now this is the picture. See, this is the RDD, partition 1, partition 2, partition 3. Okay, so the moment I ask the RDD dot persist, okay, that means this one partition went into memory, one partition went into memory, one partition went into disk because it's memory and disk. It will try to put everything into memory only, but if it doesn't happen, then it will try to put it into disk. Okay, similarly, uh, one more example. What is this? No, I cannot see this maze. Okay. Okay. So for now, that's what I wanted to say. Like, so what is this memory and all? So just you might have got some idea, right? Fair idea on this thing. Okay. Now let's start data skewness as well. I know it's a bit late, but yeah, just quickly introduce this data skewness. How Spark occurs. Simple. Let's say you have let's say 100 200 tasks. It's very famous problem. Okay, so 200 tasks. Okay, out of those 200 tasks, 199 tasks are completed very fast, but one task is taking so much amount of time. Let's say this 199 tasks are completed in with 1 minute for each task, but this one task, right, 200 tasks is taking around 1 hour. You got that right? So out of 200 tasks, 199 are completed very fast within 1 minute. But this extra 200 tasks, right? It is taking almost 1 hour to complete. That means the task has so much amount of data that it needs to process. But other 199 task has very less amount of data. They processed very fast. But your job will get completed if and only if all these 200 tasks are completed. That means maybe 199 tasks are completed in 1 minute. Still, I need to wait for this 200 tasks to complete. That means that's an issue. That's what we call as data skewness. Okay. So data skewness in Spark occurs when data is not evenly distributed across the partitions, not distributed evenly across the partitions. Let's say the partitions. Because partitions will define the number of tasks you can work in parallel, right? Because what is task? Task is the smallest unit of work that you can do on top of a partition, right? So if that partition is not done correctly, then some partitions will have high amount of data, some partitions will have less amount of data, right? Then you will have some issue. Okay. Okay, so this often happens when certain keys in your data have more values than others. Okay, so let's say there could be sometimes we will do group by Okay, group by or partition by those kind of stuff. So then if you do that, then one key, let's say you go with the keys. Okay, let's say customer only. Okay, I told you, right, one customer placed 4.9 orders in a year. Let's go with that same customer. In the parallel universe, that same customer placed 10,000 orders in an year. Okay, and the other 9 customers placed only 10 each. 10 each. That means this person placed 10,000 and the other one plays 90 only. 10,000 total, 10,090 tasks. Now, if I group, if I wanted to divide this data by customer, that means this customer one is so much amount of data. Customer 2 to 9, 2 to 10 will have very less amount of data, and they will this 2 to 9 customers data will be processed within just 1 minute, less than 1 minute. But this 10th customer one data will take more than 1 minute because it has so much amount of data, right? So that's a skew problem occurs. Our job will completed if and only if all these customers data is processed, not only single customer, right? All the customers, 10 customers data needs to be processed, then only this job is completed. Okay, so that's introduction I wanted to give. But yeah, tomorrow we can discuss more on this skewness and how we can resolve that skewness. But this repartition, right, if you see this repartition police came here. Okay, so you know, right, repartition is to increase or decrease the number of partitions in a radio or data frame. It can cause the full shuffle of data. That is, data is reshuffled across the network to create new partitions. Okay. So if it comes to coalesce, the method is used only to reduce the numbers, and it avoids full shuffle. It will do minimum shuffle. Minimum shuffle. The less amount of shuffle it needs to do, so that we can have the reduce the number of partitions. Okay. So it will try to minimize the amount of data that shuffled. Okay. This is less expensive. This is more expensive. Okay, and it can lead to data skewness if you have fewer partitions than before, because it combines existing partitions to reduce the total number of it. So this skewness we will discuss. Okay, but yeah, this repartition police you can just go through this. Okay, then sorting and everything I will lecture. Okay, and RDD data frame dataset I will know that I will tell you the difference. But I really request you to just go through this document again so that you will understand
Boleh kan
most of
college
the.
sound ekata
Okay,
ne?
so that's it. So any doubts so far in this class?
No doubts.
Hello.
No doubts. No doubts.
No
No,
doubts.
sir.
Okay. So hope you got some idea. See, first time when I listen these concepts, even I'm with a blank face. Okay, it happens. But I didn't let that happen to me. So I just went and I just practiced and then came back again. Okay, so that's what I am expecting from you. So I know you will have blank faces or some concepts are very hard to understand, something like that. But that's okay, no problem. So it happens with everyone. But just go and prepare something. Okay, with whatever. If it's easy, again, if it's easy, everyone will do it. If it's hard, only few will do it. Okay. I think only if you're only you belong to the few people, 1% of people. Okay, 99% will leave it the moment it feels hard. Okay, just try to do that in case of any doubts or anything. Because you guys, I'm not sure either you started practicing SQL, Python. I'm not sure. That's the most important concepts. Okay, so the moment you go to interview, the first question they will ask is SQL or Python only. Okay, then they will move into PySpark, all these kind of concepts. Okay, just try to practice more. Okay, utilize your time wisely. Okay, time lost will never come again. Okay, just try to use your time wisely. Okay, so any doubts? If no doubts, we can wind up.
Sir, that PDF is sent in WhatsApp.
Sorry, that
PPT
PPT
sent.
I will send. Ah, that I will
And
send.
topic on the
Topics
Sunday
on this
topic.
demo, right? Sunday class, Sunday demo. Okay, okay, I'll send you the topics as well. Okay.
Topics.
Yeah, topics also. Topics is meant nothing but that. See, today and tomorrow maybe I will cover. Today I covered few concepts. But tomorrow I will cover these concepts as well. So out of these concepts, you need to come up like only the known concepts to you, right? Till Spark Submit, I think I will complete tomorrow. Memory management, leave it to me. It will take at least 2 to 3 classes. Okay. So memory management, you can leave it. I'll tell you memory management use cases. Let's leave it. Okay. Broadcast accumulators, failures, code level, resource level, best practices to design application design. Okay, so now only I'm telling that concept is till this phase. understanding Spark subnet till this place, till this page. Okay, so this page number is 12. Okay, so the first PPT completely, and this 12 pages, first 12 pages in the second PPT. That's it. So till here. So what are the concepts we have? I want every concept to be touched in your demo. Every concept.
First
Okay.
12 pages we have to.
Not only 12, along with the first PPT, right?
Okay, sir.
Yeah. Okay, so till this 12 page. Okay, you can mark it here. So so till 12. What is this? Okay, till this 12. Till this 12. So memory management you can ignore. Memory management is a very high level advanced concept. I need some good amount of time to help you understand this memory concept. But till this Spark submit, we will complete tomorrow. Okay, we will complete this Spark submit. Difference between this data frame dataset and RTT. This skewness you already have a fair idea. I hope so. Tomorrow I will tell you salting the few techniques how you can avoid the skewness. Okay, but yeah, so this document you need to go through definitely, and the first PPT as well. Okay, so just go through that. That's it. Okay. Okay, so that's it. So let's continue. Okay, thank you. Thank you. Bye. Let's meet in
Thank you.
tomorrow.